Assalamualaikum everyone. So for our group 3, we are about to show to you about sulfur acid and paper and pulp industry. We heard about paper, but do you heard about pulp? Sooner or later we about to explain to you guys. So we go to the properties, which is the atomic number is 16, and it is related to the electron configuration here. We can see 1s2 until 3p4. So when we total up all the small numbers here above the orbitals, so we got the atomic number back. So it is the total of the electron number and also the proton number. So we go to the atomic weight, which is 32.064 gram over mole, and also oscillation state, which is it can lose or gain. It is the situation where it can lose or gain weight, which is when -2, it gain electron. So +4 and +6 when it loses electron. So in the group of polyatomic numerator, which is the group of the two neighbors left in the periodic table before the noble gas. So noble gas is the 18, the group of 18. So it is the 16 group. So there it is, group 16. And also at the P block, which is when we can see at the periodic table, it is on the right. Okay. So it is the period 3, which is when we observe at the periodic table, the helium and the hydrogen is the first row, so period 1. So it is at the period 3, which is the row number 3. Okay, next. So we go through to the rhombic and monoclinic, which is rhombic sulfur is a crystalline allotropic form of sulfur that has rhombic octahedral crystal. And also the monoclinic sulfur it is a crystalline allotropic form of sulfur that has needle like and long crystals. And also you can observe density at 20 degrees, the both of them, and melting point the both of them. So conservation into other forms. It can be rhombic to monoclinic and also monoclinic to rhombic. So if we hit the rhombic sulfur onto certain degrees, it slowly converts into monoclinic. So vice versa to the monoclinic, which is monoclinic when we hit at the 94.5, so it can be at rhombic form. So the method of operation of both of them, on rhombic we can starts with a dissolving of sulfur powder in carbon disulfide, and also for monoclinic it starts with evaporation of sulfur powder on an evaporating dish until it melts. So you must have been asking about why rhombic, why monoclinic? It's because of the sulfur. It won't stable itself. It isn't stable when in a original state. So it has to be in rhombic structure or monoclinic structure. Okay, next. So for the boiling point on alpha form, for the rhombic thing, it also called as alpha form, and also for the monoclinic, it's called beta form. You can see this, the structure of the alpha and beta form. Yeah, see that. So for the color of them, it seems the same, but really differ of color of the yellows. So for alpha form is more brighter than the beta form. So the beta form is rather paler whitish yellow. It's rather pale or yellow. So the both allotropes, the both of them, does not dissolve in water. Okay, that's all from me, and you can see this the color of me. That's all from me. Next, I will pass to Hilman for the further slides. Okay, thank you.
So the chemical properties of sulfur, it can react with oxygen, as you can see in the slide, which produce sulfur dioxide, and can burn and produce a pale blue flame and a strong shocking odor. Sulfur is also highly reactive. Because it can react with almost all elements except noble gases in room temperature or during heating process. So next, many important metal ores are compounds of sulfur, either sulfide or sulfate. For example, such as cinnabar, mercury sulfide (HgS), stibnite, antimony sulfide (Sb2H3), and galena, a lead sulfide (PbS). So next, the importance of sulfur. So sulfur is used for production of sulfuric acid. Sulfur is also used in making fertilizer. For further information, sulfuric acid can be an effective cleaning tool for cleaning a clogged drain. It's also simple to use, and sulfuric acid can chemically break down many materials. So sulfur is also used in treating copper ores, and sulfur is used in the paper industry, which will be discussed later. Sulfur is also used in production of agriculture chemicals and production of synthetic rubber. So as you can see in the slide, there is a shoe sole and a tire, which is both is a synthetic rubber, and sulfur is used for production of both of these synthetic rubber. Finally, sulfur is also used in treating skin disorder. For example, acne, scabies, or redness on your skin. Sulfur will be used as an ointment to treat both of these skin disorder. So finally, there's the disadvantage of sulfuric acid. It can produce chemical burn. Chemical burn, which will occur when sulfuric acid is in contact with our skin, so it can produce a secondary burn, as you can see in the slide. So it's highly dangerous for us. So please handle it with care. And also, will produce fumes that can burn our lung. It's also highly corrosive. Because it's corrosive to metals, living tissue, and stone at high concentration. So next, sulfuric acid can also burn our cornea, which is in our eye, and lead us to blindness if it is splashed into our eye. And finally, it can pollute our environment by producing acid rain and pollution. This will damage our environment. So that's all from me. Thank you.
I'm Daniel from Group 3. So I'm gonna present to all of you about the craft pulping process, resuming the presentation of Noor and also Hilman. So what is craft pulping process? Actually, craft pulping process is the most popular use of paper pulp process. It is a process for conversion of wood into wood pulp, which consists of almost pure cellulose fibers, the main component of paper. It depends on sulfate to create alkalinity in cooking, which is why it is also known as sulfate process. So the material comes from wood fiber from sawmills, recycled newspaper, some vegetable matter, and recycled cloth. Other materials used in paper manufacture include bleaches and dyes, fillers such as chalk, clay or titanium oxide, and sizings such as rosin, gum, and starch. So let's talk about the manufacturing process. So for the making pulp, several processes are commonly used to convert logs to wood pulp. In the mechanical processes, logs are first tumbled in drums to remove the bark. The logs are then sent to grinders, which break the wood down into pulp by pressing it between huge revolving slabs. The pulp is filtered to remove foreign objects. In the chemical process, wood chips from debarked logs are cooked in a chemical solution. This is done in huge vats called digesters. The chips are fed into the digester and then boiled at high pressure in a solution of sodium hydroxide and sodium sulfide. The chips dissolve into pulp in the solution. Next, the pulp is sent through filters. So here, bleach may be added at this stage or colorings. Then the pulp is sent to the paper plant. So the second step is the pulp is next put through a pounding and squeezing process called beating. So inside a large tub, the pulp is subjected to the effect of machine beaters. At this point, various filler materials can be added such as chalks, clays, or chemicals such as titanium oxide. So these additives will influence the opacity and other qualities of the final product. So for the third step, which is coating, so pulp is fed into the machine on a moving belt of fine mesh screening. So the pulp is squeezed through a series of rollers, while suction devices below the belt drain off water. If the paper is to receive a watermark, a device called a dandy moves across the sheet of pulp and presses a design into it. Okay, so the next step is the removal of water. So the paper then moves on to the press section of the machine, where it is pressed between rollers of wood or rollers of wool felt. Sorry. So the paper then passes over a series of steam heated cylinders to remove the remaining water. So for the final step, finally the dried paper is wound onto large reels where it will be further processed depending on its ultimate use. The paper is smoothed and compacted further by passing through metal rollers called calendars, a particular finish, whether soft and dull or hard and shiny, can be imparted by the calendars. So basically that's all for the craft pulping process. I'll be giving the presentation to Jaren. Thank you.
Hi everyone, I will continue to present from tall oil splitting. So what is tall oil? Tall oil is an important product of chemical pulping process and is used to improve the economic feasibility of craft pulp mill. So this is the general process of tall oil. From the wood chips, we'll use it to turn it into paper, and the remaining black liquor we'll turn it into tall oil. So this is a picture of crude tall oil. So for the first process is acidulation. We will add spent acid to tall oil soup. Spent acid is the unreacted acid from the main reactor where the acidulation reaction occurs. It's produced during processing of petroleum sulfonates. The concentration will be around 70% as sulphuric acid, and it is in liquid state. So the second one is batch process. This is the best condition for the process, and in this process, soap is heated to boiling with steam, and the sulphuric acid is added. So the resulted mixture is generally allowed to settle overnight. The crude oil will go into this biorefinery tank. After that, different layer will produce different type of oil, and this is all the example of the end products. You can pause this video to read it. So this area is advantageous for biofuels. Next is chlorine dioxide generation. Chlorine dioxide is very necessary for paper industry to blanch wood pulp. So this is how the brown wood turn into the white paper that we see today. So how we produce it? We use sodium chloride to react with one type of acid. We use sulfuric acid here, and one type of reducing agent. We often use methanol or hydrogen peroxide to produce 6 molecules of chlorine dioxide and 6 molecules of sodium bisulfate, and also the last carbon dioxide. So this is the result, the reaction tank. So we will use sodium chloride and one type of reducing agent and also acid mixed in the generator, and this absorption tower is to absorb the carbon dioxide, and the last will produce chlorine dioxide. So it's used to blanch the pulp, and we will get our final product, which is paper. The third one is adjustment of pH. So the downside of sodium bisulfate is a fairly high pH. So where do we get this sodium bisulfate? Is from the chlorine dioxide generation. So we'll use sulfuric acid to neutralize it. The picture is sodium bisulfate used to increase pH value for swimming pool. And why sulfuric acid is commonly used is because it's cheap, and the typical concentrations are 25% to 96%. So it is more potent than all acids. From this chemical formula, we can see that they have more hydrogen ions than others, like chloric acid and etc. So this is at the end of this presentation. Thank you everyone.